All right, let's talk reality. What is reality, and why am I talking about this now? Well, the reason why I'm talking about it is that most of us are not living in reality, we're living in the past. There's an old saying by a scholar I can't quite remember that basically the common population, the average person, is about 200 years behind where current science stands. 200-year delay. So most of us are living in a Newtonian worldview. This worldview was developed by a brilliant human being, Sir Isaac Newton, who lived in the 18th century. He's famous for what he wrote as the Philosophia Naturalis Principia Mathematica, or simply the Principia, where he outlines the laws of motion. If you recall from physics in high school, those scenarios where a ball was thrown in the air and you can use some basic calculus to determine where the ball would land, that's the work of Isaac Newton. And the significance of this philosophically, the implications, was that it created a physical, mechanistic worldview. So mechanistic that if I had a God's eye view of all the atoms in the universe in a given time and knew their velocity, I could actually predict the future. So it created a physically reduced world where all interaction is physical, governed by physical laws, physical principles. Objects interact through forces such as electromagnetic forces, and therefore objects are separable. So, in other words, if you separate objects far enough where physical forces cannot interact, those objects, therefore, cannot interact. There's a separability component, all right? Most of us envision things even as small as atoms as little marbles floating around within us and around the universe. And we live in this world, which has significant philosophical and spiritual implications. So we're going to go into delving where science currently stands. And everything I'm going to review is more or less orthodox, established science that I will encourage you to delve into further because I can only scratch the surface. So, when did the Newtonian worldview break down? Well, the proverbial shit hit the fan in what's called the double slit experiment. This all began as a discussion or a dispute over what is light? How does light manifest? Now, Newton said that light manifested as particles. Okay, that is what he believed. They manifested as particles. But there's a simple experiment done by Thomas Young in 1801 using a double slit experiment where he proved that light was not a particle but a wave. And to illustrate how this is done, here is a single slit experiment with a paintball gun. So you have a panel that has a slit in the middle of it, and then you have a screen in the back that catches the paintballs. And if the object that's being shot through the slit is a particle, what you end up having is a single band pattern that is consistent with particles. And you can actually outline the particles as well. So therefore, if we do a double slit experiment and we're shooting particles through, what we would expect to hit the screen are two bands, okay, if something is a particle. Now, what's interesting is when Thomas Young shines some light through the double slits, he didn't get two bands, but rather he got multiple bands. Now, why is that? Well, if we're dealing not with a particle but with a wave, when the wave hits the double slits, it creates two mini waves. The waves interact, collide, and cancel parts of each other out, and what you're left with is an interference pattern on the screen. So you'll see a band, space, a band, space, a band, space. Here's a more psychedelic demonstration of this. Wave coming through, interference, an interference pattern at the end. And here's another demonstration here. Now, what you're seeing is weird because the end results are particles, but they're showing this interference pattern, which suggests that light had to have been a wave. And this is mutually contradictory because a wave is a spread out thing and a particle is a concentrated sort of thing, okay, which therefore they're contradictory, they're exclusive. And we see the same phenomena with atoms. So when we're able to develop this experiment with atoms, we see the same thing. This is a phenomena in the microscopic world, although they've been able to demonstrate this wave-particle duality even with larger objects. I believe several atoms, I think they even, a virus, they were able to demonstrate this with, if I'm not mistaken. But this is absolutely bizarre, and I'm just going to continue explaining this so that it gets more bizarre in your head, and then we'll unpack it more. The atom does not exist until it is observed. The atom does not exist until it is observed. So you're saying, well, before it hits the screen and it's observed, where is it? Well, technically, it's in what's called the wave function. Now, the wave function is the mathematical probability where the atom can be found. Okay? Found. Not where the atom is. All right, that's a very important distinction. The wave function is the probability where an atom can be found upon observation. It is not where the atom is. Without observation, the atom exists in what's called a superimposed or a superposition, okay, where upon observation, it technically exists in, I'm contradicting myself, it technically can be found in the wave function upon observation, okay. So how does this work, or how can we delve further into just how bizarre this is, where there's the famous Schrodinger's cat thought experiment, where Erwin Schrodinger, another brilliant human being, he was into Vedanta philosophy, very interesting guy. He said, well, what if we have this thought experiment where I have a projector that shoots out an atom. It goes into a box that has a Geiger counter. If the box is hit, if the Geiger counter is hit, it unleashes a switch. The switch breaks a bottle of cyanide, and the cyanide therefore kills his cat. You know, very morbid thought experiment. Well, what we're saying is that the atom, because it hasn't manifested, it both hits the switch and doesn't hit the switch. Okay, it's a superposition state, and therefore you're left with two realities simultaneously until it is observed by a person. Okay, arguably a conscious entity. All right. Now here is what gets even stranger. It is not merely the current state that is observed, but the past, the history gets created. So if you were to walk into this situation, if the cat in this whole contraption was in a room that was closed, and you were to walk into this, well, the superposition of the cat would collapse into either a living or a dead state, but so would all these other pieces that led up to the cat. So in other words, history would be created. Okay, so if you found the cat dead, you'd find the cyanide broken, the switch, enacted, and the electron would have hit the Geiger counter, which hit the switch. Okay, the history gets created. And this is all part of another concept called quantum entanglement. Okay, the cat, the cyanide, the switch, the electron are all entangled until they are observed, and therefore they are in a superposition that is not collapsed until arguably conscious observation. Now, you can see why something like this, if this is reality, would cause a lot of controversy. And this formulates what became called the Copenhagen Interpretation, which was developed by Niels Bohr. Niels Bohr developed the principles of this, or, well, not just him, but his team. And the principle we're dealing with, well, when the wave function collapses, what determines whether the cat is dead or alive? In other words, what determines whether the atom was in a superposition that triggered this device or not? Well, according to Niels Bohr and his team, or the orthodox interpretation of quantum mechanics, is that it is random. It is intrinsically indeterministic. We cannot know. Okay. Correspond this with the Newtonian worldview, which is deterministic. We could know. Quantum physics, we cannot. All right. Now, this rule, the Born rule, the wave function of a system yields probabilities for the outcomes of measurements upon that system. Again, this is what I've been saying several times already, is that the wave function is the probability where the atom can be found, not where the atom is. Although it's almost written in such a way that you wouldn't be able to notice that. Okay? But nonetheless, this is the case. Now, again, we're essentially saying that reality, in some sense, is disproven. Okay? And to illustrate this further, there's been multiple variations of the double slit experiment. So here is one where an atom is shot and it hits a mirror. The mirror splits the wave function, okay, into two, and then the wave function goes into a box, a microscopic box, and then each box has a little door on it that can be opened. So the wave function has been split in two and is simultaneously in two boxes. If we open the doors to both boxes simultaneously, we end up with the interference pattern, showing that whatever was in here was therefore the wave. The wave was split, and we have an interference pattern. But if I open the box one at a time, and let's say I open the top box and I find an atom inside, the wave function collapses into a single particle in one box. So you might ask, well, what happens here? What happens to the other box? You find the other box empty. All right, so let's look at this at another way. The wave function is split by a mirror. The wave function goes into each box. The boxes are closed. Now let's say the opposite happens. I open one box and I find it empty. When I open the other box, I'll find an atom, a single particle atom. Now, the significance of that is that in this case, it wasn't observation that collapsed the wave function. It was knowledge. My knowledge of knowing that there is no atom in this box collapsed the wave function in the other box. And that is absolutely mind-blowing, that is what's occurring. And no doubt, there was much debate about this. So the Copenhagen Interpretation came out in the 1930s. Okay, we're talking like nearly 100 years ago. All right, where this is being debated, and I wonder. I mean, I didn't learn about this very much in school. This should be the foundation of what we learn about. But to take this point further, it was resisted. Copenhagen was resisted by none other than Albert Einstein in what became a very famous paper, simply titled EPR, after Einstein, Podolsky, and Rosen, who were two other physicists. And they wanted to challenge the Copenhagen interpretation because obviously they didn't like the fact that we're saying things aren't real, they're not physical until they're observed. All right, the idea that an observer that is, let's say, conscious human being is creating reality. They don't like that. So, what Einstein proposed, just to summarize this real quick, is that, well, he challenged this, saying that we can't know, um, let's say, the wave function. Um, he challenged this by saying, well, if we can know something physical, the physical property of an atom, before it is observed, then that means that that atom must be physical in some sense. Now, he used what would become a twin photon experiment. And the reason why he used twin photons is that twin photons are polarized. Okay, if you don't know what polarization is, just do a quick Google of that. But they're polarized in the same direction. So what he said is that if we had, let's say, twin photons that are shot in opposite directions, and we captured one of them, if we knew the atom that we captured's polarization, then we would therefore know the polarization of the atom that we did not capture and did not observe. Therefore, the atom must be physical in some sense, right? We cannot use the Copenhagen interpretation that it's created, it comes into existence, or it's created upon observation. All right. Now this created a debate that lasted for decades, until the 1960s, when an Irish physicist, John Stuart Bell, proved via what became known as Bell's theorem that Einstein was wrong. Einstein is wrong. Therefore, the Copenhagen interpretation has been vindicated, at least the elements that recognize that in some sense the atom is only, let me just be more specific. The atom is collapsed into a particle upon observation. Now, what observation means, there's another physicist, von Neumann, who said that observation has to be collapsed by, observation terminates in a conscious observer. Okay, in other words, consciousness is what collapses the wave function. All right. So this is the reality we live in, folks. Everything is entangled. All right. We all originated from a Big Bang. Everything is entangled. Everything is in some sense united in one. Reality is a more complex thing than we know. The atoms, I mean, literally, like almost like it says, we are made out of nothing. Out of nothing, we are made out of. But more significantly, you must remember that you are not a meat popsicle.